Welcome to this tutorial. The question says a spring with its upper end fixed hangs vertically alongside a meter rule. The lower end of the spring gave the following readings in table C1.1 when various masses were hung from it. So these are the readings that it gave. We can see here the readings that were given. Then you have got the mass, which is in kg. Then they want extension and applied force. Here there are some blank spaces and they want you to fill them. The first question says state Hooke's law. So I will start with the first question. Hooke's law states that Hooke's law states that extension of a loaded spring is directly proportional to the force applied, provided the elastic meat is not exceeded. So Hooke's law states that extension of a loaded spring is direct proportional to the force applied, provided the elastic limit is not exceeded. That's what Hooke's law states. I'll shed more light on Hooke's law in the group as I explained through the voice note. So don't worry about my voice, I've got a flu. Question B, it says copy and complete the table for the values of applied force and extension produced. So applied force, here you can see it is blank. So when you see force, what formula comes into your mind? The formula that comes into your mind, it is this one: force is equal to mass times acceleration. That's the formula should come in your mind. And here, mass that you are dealing it should be in what? In kgs. If you are given mass in grams, you have to convert it so that you find force. That's what we are going to do to find this one. Now, luckily in this question, we are given the mass, which is in what? In kgs. It is not in grams. So if it is in grams, you would be prompted to convert it. You can't go just directly. So then acceleration, when you are not given, you know that acceleration when you're not given, you are supposed to use 10 newtons per kg. That's the acceleration. That's what you are. So you have to use 10 meters per square second. This is the acceleration that you're supposed to use when you are not given in the question. So now let's answer this question. So for us to fill here, we are going to multiply mass by 10, which is in kgs. Here we have on top of the mass there, it is 0.02. Then when we multiply by 10 this one, how much are we getting? We are getting 0.2 newtons. So here it will be 0.2 newtons. This one by 10, it will be 0.4. Here to give us 0.6. I hope you know the procedure I've shown you. Here it will be 0.8. Here they already found the answer. Now on extension, for us to find extension, we use this formula. Extension is equal to original length minus recorded length. That's how it is. So here, what I'm trying to say, then they say that here extension, I've seen these centimeters, they are telling you that extension should be in centimeter. If they wrote here millimeter, we would be prompted to convert centimeters to millimeters. So now, here you have seen this first value, which is 10. What they did first, they subtracted 10 from itself. That's how they came up with this 0. Then they were subtracting this 10, the first value which is here. They are subtracting from this one, this one, this one, this one, and this one. That's why you can see that for them to have 7.5, they did what? 17.5 minus this 10. They got 7.5. That's what we do when you're dealing with Hooke's law here. So what will happen here? 12 minus 10, that will be how much? 2. 14 minus 10, that will be 4. 16 minus 10, that you subtract the first number. There are no sense to subtract. So here it will be 16 minus 10, that will be 6. 17 minus 10, that will be 7. Yeah, done. So we are done filling the table. So here I didn't want to copy it here, but as in the question you'll be given the answer sheet where you have to fill. Now they are saying draw a graph of applied force against extension on a graph paper. In an exam, the graph paper is always provided. Now there's something that I would like to tell you concerning this question. Applied force. Which one is mentioned here? It is what? Force. The one which is mentioned will be in the y-axis. Then which one is mentioned at the end? It's what? Extension. Meaning extension will be in the y-axis, in the x-axis. That's what you do when you're plotting. You should follow this procedure. I don't know if you call it Muntanga's theory. That's what I do, and it works. If you follow this, you won't go wrong. Now, so meaning we are dealing with these two, applied force and extension, these two. So we are dealing with these values. They are highly up, but these, they are not important to us. So that's the way it will be done in this place. Or I can say here. So now in terms of the numbers, these numbers you have seen, don't get them directly. The way they are, you say 0, then 2, 4, then comes 6, then comes 7. The number should be uniform. Like when you look at this one, okay, it was going very well. 0, then 2, then 6. Okay, that shows they were adding 2, they have 6. Then up it becomes 7. So if I start going like 2, 4, 6, 8, 10, these numbers going to be accommodated. So meaning, in short, in physics, you have to come up with your own scale. It is not like mathematics where the scale is provided for you. So even here on force, you have to do the same. Now, like when I look at which are here on applied force, they are already uniform. So, and in physics, don't forget your title. Your title will be this one, applied force against extension. So now, see what I've done on the graph paper. So your title, you write force. Yeah, force, it is supposed to be force against extension. Sorry, I wrote again. So here, now what you are going to do, we can see there is what on that table. We have this one 0, 0, so I guess it's more like 0, 0, right? So you have to go where there's 0. Yeah, and you have to indicate. You have seen the way I wrote here. I've written like for force 0, 2, 4, 6, 8, 1. These numbers are already uniform. Even here, I just wrote up to the end. Then I have to include to label the axis. This is the x-axis, this is the y-axis. So here 0, 0. Then which other point? It's to, you know, extension the x-axis, then it goes 2 with 0.2. So 2. We go where there's 2, it's here. So here to be, yeah, like that. Even if I haven't included like my point, just one and the same. This one is the same as 2.0, or I can say 4.0. Yeah, it's the same as 6.0, 8.0. Yeah, just like that. Sorry. Oh, 2, 4, 6, 8. No, it was supposed to be 0.2. Yeah, sorry, I'm correcting some mistakes. Yeah, so even here 0.4, here 0.6, 0.8. Yeah, okay. But as for you on the graph, don't use the pen like me. So we got to the next one. It says 4 with 0.4. We go where there's 4. It's here. It goes with 0.4 like this. Then we have got which one? 6. 6 there goes with the 6.0. 6. 6 goes with 0.6 here. Then 7 goes with 0.8. 7 here. We go at the 0.8 like this. Then we have got 7.5. 7.5 goes with what? With 1. So we go where there's 1, it's here. So now we know that here it's what? 7, okay, so when you reach here. So here we got like this 7.1, 0.2, 0.3, 0.4, 0.5. So 7.5 is here. Then you get your ruler like this. You have seen what I've done. You start joining the point. That's what you are going to do. You use your ruler. Then here what you are supposed to do, then you have seen I use the ruler. Now here you can proceed using the, it will bend. So just use free hand like this. That's all. Then it means you are done plotting, So then the last question says, on the graph show the elastic limit. So the elastic limit is where it started bending. Where did it start bending? It started here. So you include like the issue by writing like this. Then you write elastic limit. Yeah. Then it means you are done. You have seen the way I've drawn it. Yeah, so if you have got question, you can ask in the comment section. God bless you, and don't forget to subscribe to my YouTube channel. God bless you.